everyone, welcome to my channel. In this video we will learn about the channelization access in the multiple access protocols. So channelization is a multiple access method in which the available bandwidth of a link is shared in time, frequency or through code between the different stations. So in this section we will discuss three types of channelization protocols, that is the frequency division multiple access, time division multiple access and code division multiple access. So in the first one, that is the random access protocol. So every station will be having equal access to the equal right to the channel. In the case of the control access protocols, a station will act as a master and the remaining stations will act as a slave. So the master, the primary station, will be having the right over the channel. But here, so we are dividing the given bandwidth into time, frequency or through code, and we are sharing it among the different stations to transmit the data. So we will see in detail about the channelization protocols here. So first one is the FDME, that is frequency division multiple access protocol. So here the available bandwidth is divided into equal bands so that each station can be allocated to its own band. Okay, so we can see in the diagram, so four stations are there which are ready to transmit the data. So in the case of frequency division multiple access, so we are dividing the bandwidth. So we are going to divide the bandwidth of frequency bandwidth into different equal bands, and we are going to allocate the equal bands for each and every station here. Okay, so FDMA splits the radio frequency channel into multiple sub-channels, that is into smaller parts. So here bandwidth is separated into different frequency bands and each station is assigned a band to transmit the data, and that band is always reserved for that station. Unused frequency bands that prevent the interference from the stations is called as guard bands. Okay, so there will be some unused frequency, right? So here the channel station 1 is having the frequency with the blue color, so it is accessing the bandwidth to blue color here, right? So it is mentioned in blue color, and the station bandwidth accessed by 2 is in the yellow color. So the gap between these two bandwidth is called as the guard bands, that is the unused frequency bands. So guard bands is also added so that no two bands overlap to avoid the crosstalk and noise. So here the green color represents the bandwidth accessed by the station 3, and the pink color will represent the station 4 accessing the bandwidth in the common channel. So the space between this bandwidth, that is unused frequency, is called as the guard bands, and it prevents the crosstalk and noise. It avoids the crosstalk and noise. So here the main drawback here in the FDMA is when we try to fit the more sub-channels in a channel, users will start suffering the call interference. So that is the main problem in the frequency division multiple access protocol. So next one is the time division multiple access protocol. So in this, the bandwidth is shared between multiple stations. To avoid the collision, time is divided into slots and stations are allotted these slots to transmit the data. So here the channel is divided into multiple time intervals and each station is allotted particular time interval to transmit the data. To avoid the collision, we are using this method. So however, there is the overhead of synchronization as each station needs to know its time slot. So there must be proper synchronization between each station to know its own time slot. So this is resolved by adding the synchronization bits to each slot. Another issue with TDMA is the propagation delay, which is resolved by addition of the guard bands. So here we will see how the transmission of the data is done. The station 1 is accessing the time slot, so it is represented in blue color, and the time slot used by the data station 2 is in yellow color, and 3 is in green color, and 4 is in the pink color. Okay, so here the station 3 is silent and the remaining stations are accessing the channel. So the unused time slot is called as the guard bands here also. So here in the TDMA, bandwidth of channel is divided into various stations on the time basis here. There is a time slot given to each station. The station can transmit the data. The TDMA requires the synchronization between the different stations, and it is the type of access method in the data link layer. And each station data link layer tells the station to use the allocated time slot. So next one is the code division multiple access. So one channel carries all transmissions simultaneously. So there is neither division of bandwidth nor division of time as in the previous methods. So it is a combination of the FDMA and TDMA. Okay. So all stations can transmit the data simultaneously here. It allows each station to transmit the data over the entire frequency all time. So multiple transmissions separated by unique code sequence. So each user is assigned with a unique code, and it is a combination of the TDMA and FDMA. So it combines both the TDMA and FDMA. So for example, if there are many people in a room all speaking at the same time, then also perfect reception of the data is possible if only two persons speak the same language. Similarly here, data from different stations can be transmitted simultaneously in the different code languages. So that's why each station is allocated a code to transmit the data. So here each station is allocated a code to transmit through the channel, the single channel. Okay. To avoid the collisions in the channel, so each station is allocated a code to transmit the data in a common channel. So it combines the both advantages of the FDMA and TDMA. So here the station 3 is combining the data and code of the station 3, and station 4 is combining the code and data of the station 4, and station 2 is combining the data and code of the station 2. So and it is combining it, and by using some mathematical formula it is transmitting it to the channel. So here the channel is divided into a different code, different bandwidth of code to transmit the data. So these are the different types of channelization access protocols. Thanks for watching my video.